Hello everyone. So today we are going to solve this LeetCode hard problem, maximize Subarray GCD score. So let's go through the problem statement once, and we'll see what we need to do here. So we are given an array of numbers, and we are also given this value k. So the k denotes the number of operations that we can perform on the given array, and in one operation, what we can choose any element in the array and double its value. And for example, if we are given like nums equals to 2, we can choose 2 and double it to 4. And one more condition is there, like we can only double an element at most once. So we cannot double a single element. Like once we have made this element as 4, we cannot double it and make it as 8. Okay, so k is the number of operations that we can do in each element, and each element can only be picked once. Now we are given a score, GCD score of a particular array, which is defined as the GCD of all the elements of the array into the length of the array. So the score of a continuous subarray is product of its length into the GCD. Now what we need to find is, we need to find out the maximum score that we can achieve out of all possible subarrays of the given array. So for example, for this nums equals to 2, 4, out of all possible subarrays like 2, 2, 4 and 4, we need to find out the maximum score that we can find. And the score is the residue of all elements into the product of its length. So if we go through the given example one, so here we are given k equals to 1. So if we double the 2 here, the array will become 4, 4, and this subarray has GCD 4 and length 2, so score will be 2 into 4 equals to 8. So here the maximum possible score is 8 only, and hence the output is 8. And so one key observation that we need to make here is, like, since we are only allowed to double a given element, hence maybe in the prime factorization of each element, we try to segregate the powers of 2 and the remaining part alone. So for example, like, for a given number x, if we can segregate the power of 2, like 2 ki power count, and the odd part. For example, if we have 2, the odd part will be 1 and the power of 2 will be 2 to the power 1. For example, we have 4, then the odd part will be 1 and the power of 2 will be 2 square. So in if we will try to segregate, means break a number into its odd part and the power of 2 part. Why we are trying to do that? Because since we are only handling in the powers of 2, if we have already segregated the powers that we have, then if we multiply, we just need to handle this count variable that we have here, other than, instead of multiplying x in by 2 and then means finding out the GCD in a brute force manner. Because since we are given n as 1500, so we can iterate through all the subarrays once, means n square is allowed, but for a given subarray we need to means find out the solution in constant time. So for that we need to do some pre-computation thing. So for that we are calculating this 2 to the power count. So for example, if we have nums equals to 357, so the means 3 will be 3 into 2 to the power 0, 5 will be 5 into 2 to the power 0, 7 will be 7 into 2 to the power 0. So the odd parts will be 357 and the counts will be 0, 0 and 0. And similarly for like nums equals to 468, the odd part will be 1 and the count will be 2. So this means, I assume that you get what we are trying to do here. We are trying to break the number into its power of 2 and the remaining odd part. And it will be odd only because if it is even, then the means we can further break it into powers of 2. Now, once we have this, the final GCD of the array will be the GCD of these odd parts that we have, like GCD of 1, 3 and 1 into the GCD of 2 ki powers that we have, like 2 ki power 2, comma 2 ki power 1, comma 2 ki power 3, and we will multiply these GCD so to find out the overall GCD of the given array. And now the GCD of means this formula should be clear, like GCD of 2 ki power a comma 2 ki power b will be the this minimum power that we have. For example, we have 2 ki power 2, 2 ki power 1 and 2 ki power 3 here. So here uh, uh, here the GCD will be, means we have 2 to the power 2, 2 to the power 1, 2 to the power 3. So GCD of all those will be 2 to the power 1 only, the minimum power that we can get. So this is what we are trying to do here. And once we have this, we derive the final result as GCD of odd parts, that is here, that is uh, GCD of 1, 3, 1 into GCD of 2 to the power 2, comma 2 to the power 1, comma 2 to the power 3, which will be like GCD of 131 will be 1 only, and GCD of 2 to the power 2 is 2 to the power 1, so 2 to the power 1. So it will be 2. So in this manner, we can easily find out the GCD on the basis of just odd parts and the minimum count, minimum value in the count array that we have. So here the minimum value was 1, so it was 2 to the power 1. I hope you get it. Like, for example, we have x1 equals to a1 into 2 to the power 5, 2 to the power 3, and 2 to the power 7. Then the minimum power that we have here is 3. Hence, the GCD of these powers part will be 2 to the power 3. And we can compute the GCD of odd parts and GCD of a1, a2, and a3. So here the minimum value is 3, minimum power is 3. Hence, the GCD will be 2 to the power 3. Now comes the tricky part, like how we are going to use the operation. Like we are given k, so how to use this operation. So for that, like we will only try, means we want to maximize GCD. So since we want to maximize GCD, we will like multiply those numbers with 2. Like we need to multiply those numbers with 2, which has the powers of 2 as minimum only. Because if, like for example, here we have 2 to the power 3 and 2 to the power 5. So if we multiply x1 with 2, it will become a1 into 2 to the power 6. But we do not need that. Like here, if we do this as, make this as 2 to the power 6, then the GCD of 6 and 3 will be 3 only. Hence we try to make this 3 as 2 to the power 4, so that the GCD, overall GCD can increase. Hence one observation that we can make here is we will means apply operations on the powers, on the numbers who have the powers of 2 as minimum only. For example, here x2, because 3 is minimum. Now, for example, here if k was 1, we can double exactly that element. So, like the power of 3 will become 4, and the new GCD will be, instead of 2 to the power 3, we will have 2 to the power 4. So, overall GCD would be GCD of odd parts, that is a1, a2, and a3, and the product of 2 to the power 4. Let's suppose take another example. Suppose we are given a1 equals to, means 2 to the power 4, 2 to the power 2, 2 to the power. Now here we have two values with powers, with the minimum power. Here the minimum, like minimum power equals to 2, and we have two values x2 and x4 as 2 to the power 2. So if we want to, like if we increase this value as 2 to the power 3, still the means overall GCD would be 2 to the power 2 only, due to this x2 that we have here. Hence we need to make this 2 make this 2 to the power 3 as well. Hence we need to apply minimum 2 operations here. And how do we get, means how many minimum operations we need to find? It will be the number of counts, means the number of elements who have that who have the exponent as 2. So for example, here means the minimum exponent 2 was present in two elements x2 and x4. Hence we try to, means if we want to increase the GCD, we will need to apply at, means at minimum this many operations, right? So suppose if k was 1 here, we, to raise the minimum exponent from 2 to 3, we needed to double these two elements as well, but we can only apply one operation. So the GCD will remain as 2 to the power 2 only. But if k was 2, then we can double both of them, and then the GCD will be GCD of these odd parts into 2 to the power 3. So I hope you get like how we are, means applying the operation to the number which has the minimum value only. And once we have this, the means the best GCD that we need to find is, would be for example, we are given an array, and uh, we find out the min count that we have. So we have the means I will be using these variables min, count, and min. So if we have a1, a2, a3, a4, and min count is 2, for example. Okay. So here the meaning, if we want to increase this mini, if we want to and the mini is the smallest exponent of 2. So for example here mini was 2 only, and min count was also 2 because it was present in two numbers. So if we want to increase the GCD, we need to make min count number of minis multiplied by 2. So for example here we need to apply, if k is greater than equals to min count, in that case we can increase this mini exponent, like mini was 2 initially, we can make it 3 as we discussed above. Like if k was 2 we can double both of them, then it will be 2 to the power 3. But if k was 1 means it was k was less than min count, k was less than 2, hence we was not able to increase the GCD. But if k was greater than equals to min count, then we are able to increase the overall GCD. So this is the means the best formula that we get here. Like if the min count is greater than equals to k, then the best GCD will be uh, this GCD of odd parts. G denotes the GCD of odd parts into 2 to the power mini plus 1, and mini was the initial smallest exponent in the variable in all the elements present. And if mini count is greater than k, means k is less than min count, then we'll just find out the initial GCD that we had, means we were not able to increase. So this was the case of GCD was g into 2 to the power mini, means this was the case of g into 2 to the power mini. And now this was the case of g into 2 to the power mini plus 1. And why we are able to increase mini, because k was means greater than equals to the min count. So I hope you get the logic how we need to, means how do we find out how to find for a given array, how to find for a given subarray. So for a given subarray, if we have the odd parts as well as the means power of 2's, we just need to find these two values, min count and the mini. And if min count is less than equals to k, then the GCD would be g into 2 to the power mini plus 1. And if min count is means greater than k, then the best GCD would be g into 2 to the power mini. So now we can see like how we are going to execute this. So initially as we saw, like we were finding out this counts array. So we'll initially create a counts array to store the number of power of 2's in each variable and segregate the odd parts. So if we move on to the code part, so initially like we do this create this count vector, and we find out the power of 2 in nums of I. So this count of I means power of 2 in nums of I. And now the remaining part will be the odd part, would be the remaining nums of I. Like we are modifying the original array here. So for example here if it was 4 comma 2 initially, then the means counts would be uh, 2 comma 1, and the new nums would be 1 comma 1. Okay, so this will be the odd part and this is the count. Okay, now we'll try to means create a running algorithm to find out the best GCD score using this formula for each subarray. Use means n cross n, means n, there are n square subarrays. So we'll try to simulate the algorithm for and use this formula for each subarray. So like we means create a global array to global variable to store the answer. Now we are means this GCD will be storing the means all subarrays starting from I. So this external loop is used to like calculate answer for all subarrays starting from I, and this J will be used to calculate the running GCD. So initially GCD will be 0 only. So if you know like um, if we do GCD of any variable with 0, it is x only. So GCD of 0 means GCD of 0 and any variable would be that variable only. So this logic I hope is clear. So here we are maintaining the same variables that we had initially mini, which will denote the minimum means mini from minimum exponent of 2 in subarray, and min count is that number of elements with mini as 2 to the power exponent, right? So as you can see we are doing the same only. So like we are finding out the running GCD which will be stored here, and then if the current count is less than mini, so if the current count was less than mini, we'll update the mini variable with the current count of J. And now since we have means find out the new mini variable, the min count, the count of that mini is 1, so we are making that as 1. And if we find out like the count of J's as mini, we'll update the mini. Now the result will be GCD into this is the formula for G into 2 to the power mini that we wrote above. Like initially the best GCD is G into 2 to the power mini only. And if the min count that we had was less than equals to k, then it had an extra to the power factor. So we are just multiplying the result with 2 if the min count was less than equals to k. And just we are updating the global variable with the answer, and the GCD score is this result into the product. Means initially the goal was not to just calculate the GCD, the score was GCD into length. So we are doing this part here, like result stores the GCD, and this is the length of the current subarray J minus I minus 1 plus 1. Like uh, we have the subarray from I to j. So its length will be j minus I plus 1, and the result will be storing the GCD. And we are updating the answer variable and finding out the answer. So like this was the n square algorithm for this problem. Uh, we'll try to submit this code here and see if it works. So this is the same code that we discussed previously. Uh, and as we can see, like it means beats runtime to most of the users. So yeah, and if you have any doubts you can comment, and I will try my best to resolve your issue. Thank you.